Okay, so I forgot that I wanted to talk about one more thing. Okay, so we already did the uniform circular motion, vocabulary, and properties. I want to talk about one more thing, and that's how we are going to tie Newton's first law into this situation. So we're going to look at a quick video, and then I'm going to pause it. So what we did was put the golf ball back on the paper plate. Okay. And we rolled it around. And then we had cut out a piece of the paper plate. So let's look at that again. So we cut out that piece of the paper plate. So the question is, where is that ball going to go when it hits the spot where the plate is no longer there? So we said the side of the plate was pushing the golf ball towards the center of the circle. And I want you to think about what's going to happen when it reaches that cut point on the paper plate. So before we do that, we need to look at the force diagram for the golf ball. So when we drew the force diagram for the golf ball, I'm going to draw it for that position on the plate where the plate is cut away. So I'm going to draw it for that position at the top part of the plate. So here's my plate, and I got this little thing cut out. Ooh, that's a terrible picture. Okay, so our ball rolled along this edge of the plate, and it hit this spot right here. So everywhere along this plate, the side of the plate pushed the golf ball towards the center of the plate. So the plate is pushing the golf ball in that direction. We talked about that being the centripetal acceleration, or AC, for the ball. And then we talked about, let me do a different color. Let's do black. That this has a tangential velocity. Oh, sorry. When I don't just do that with my line, it moves my line around. And it has what's called a tangential velocity at that point. When the ball was over here, it had a tangential velocity. When the ball was over here, it had a tangential velocity. So at this position right here, just before the spot where the plate is cut off, it has the tangential velocity shown by my diagram. So let's go back over here. So we have some images we want you to look at. So A, B, C, or D. The ball we used was going in the opposite direction, but it's the same kind of idea. So when the ball in these examples reaches the break in the circle, which path is that ball going to take? So take a minute and look at these. Which one do you think it is? Do you think it's A? Do you think it's B? Do you think it's C? Do you think it's D? Whichever one you're thinking it is, try to think of what your justification is for that. And then let's watch the video and see what happens. So think about A, B, C, or D. It's going to follow one of these paths when it reaches that point. Oh, there it was. Oh, I thought I added a slow motion one. Sorry. I forgot to add the slow motion part at the end. So let's go ahead. That happened so fast. Okay, let's back it up a little bit. Okay, let me... Oh, you know what? I can slow-mo this. Can I slow-mo this? Yes. Oh, I can't do full screen. Yeah. Okay, so... Oops. Okay, so let's step through this. All right, here we are, and there went our ball. Okay, so it was quick. It's like I need to fix that. I will try and fix it and post it. So if you notice at the end here when it goes real quick, it goes out and it follows a path like letter C, okay? It follows a path like letter C. So what this golf ball is going to do, and this is because of Newton's first law. Newton's first law says an object will remain in motion or at rest with a constant speed and constant direction unless acted upon by an outside force. So for the golf ball at any point on here, if we're looking at the top view, it has a normal force pushing it in towards the center of the circle. So again, this is top view. So this is if I'm looking down on the ball instead of from the side like we did last time. So that means at this position here, the force diagram would have a normal force going towards the center. Well, the minute the golf ball is not touching the plate anymore, let me do a different color. The minute the golf ball gets here, the normal force is gone. And there are no forces acting on that ball to keep it going in a circle. So it's going to follow this velocity it had, and it's going to keep going in this direction, in a straight line path from exactly the point where this force that was keeping it in a circle had disappeared. Okay, we will talk some more about this as we go and look at practice problems. But look at the practice problems for today. I'll do a couple of examples in a video for you real quick, and we can look at those. Okay, have a great day, guys.